Okay, so let's begin. This is the post midterm discussion session, and I'll outline the solutions. I won't do the arithmetic, but I'll explain the ideas of how you are supposed to, like what I think should be the way to approach the question. You might definitely have a stronger way, but this is hopefully in a bit to support people who are still confused about some of the questions. So, problem 1, as I said, no need to read all the information and the data that is given to you at the top of the question. The first thing that you can directly jump to is derive an expression for the elevator angle to trim in terms of trim lift coefficient. So, you have been given that delta E is equals A plus B times CL at trim. So, write down trim first of all, even if it is not given there. Fine. What happens at trim? At trim, two things happen, that CL trim is equals CL naught plus CL alpha times alpha trim, and this is equals to the weight of the aircraft divided by half rho v square s, which is also equal to lift by half rho v square s. Fine. And CM trim is 0, which means that CM naught plus CM alpha, also there would be a CL delta E times delta E term here, times alpha trim, this would be a trim, and this would be CM delta E times delta E trim. Oh yeah, sit anywhere. So, finally, we have, so now I go and look at the data points, like what do I need? I need to express CL trim in terms of delta E trim, and let me check what I have and what I do not have. So, I know I can get CL naught from the question, I know I have CM naught data, I know I have C capital L, fine, no need of doing 2D 3D conversion. This is CM alpha, I have CM delta E is also given and CL delta E is also given. So, the only set of unknowns that remain here are CL trim and delta E trim as well as alpha trim, which means that I have 3 unknowns, CL trim, alpha trim and delta trim, and I have 2 equations which I have to finally condense in the form of CL trim and delta trim, which means that I have to eliminate alpha trim. So, to eliminate alpha trim, it is straightforward. Go ahead and express. So, I need alpha trim on one side. So, I will see alpha trim equals CL trim minus CL naught minus CL delta E times delta E trim divided by CL alpha, and then I go ahead and plug this in here, which would give me CM naught equals 0 plus CM alpha times this thing here plus CM delta E times delta E trim. So, you will see that even in this expression, delta E trim is the only unknown to me and CL trim is the only unknown to, these are the 2 unknowns, this is known, 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 this is known. So, when you plug it in here, you will get an expression between CL trim and delta trim, which help you derive A and B. Then moving on, the next part, find the most forward CG limit for a maximum alpha 10 and deflection ranges for the elevator as given. So, whenever CG limit is being talked about, the first thing that we go and write down is the static margin. So, static margin is given as neutral point minus CG divided by C bar, which is also negative CM alpha by CL alpha. But if you wanted to find out the most forward CG limit, we would mean that we would have to write down an alternate form of this equation, where x C g is most forward divided by C bar equals negative C m alpha by C L alpha most forward. But I know that C L alpha is not dependent on the location, it is a force coefficient. This is a moment coefficient, this is dependent upon the point about which I am taking the moment. So, I know that C m alpha most forward is not given to me, but C L alpha is the same. So, the unknowns here are x neutral point and C m alpha most forward. X neutral point can be found out from the original data, where you have x C g at 0.295, the earlier configuration, for which C m alpha is given to you and C L alpha is also given to you. So, neutral point's headache is over. What I need to get is negative C m alpha most forward. For this, let me realize what is happening at the most forward configuration. So, C m C g most forward, in the most forward configuration, we have C m naught plus C m alpha most forward, alpha most forward plus C m delta E times delta E most forward. Now, when does most forward situation for the C g happen? At landing. So, and I know that I am flaring and I am trimming. So, this is going to be 0, the total moment on the aircraft. Alpha most forward, at that time I am flying at low speed, I need maximum lift. So, this is going to be the maximum alpha I can fly at. And if you are confused about the sign of the deflection, just go ahead and make a small sketch, and I know that at landing most of my pitching moment contributions are negative, which means that I have to make my deflection this way, so that a force can act which gives me a positive pitching moment and cancel out the negative pitching moment. And I know that upward is negative. So, I know that delta maximum should be, so maximum delta negative has to be applied, which means that I can go and choose this to be negative 25 degrees, convert it to radians, because everything, because some things are in radians, some things are in degrees. So, be cautious. Again alpha max is given as 10 degrees, I am given C m delta E, I am given C m naught, I will get C m alpha most forward, I will plug that in here, which gives me x C g most forward. Finally, illustrate the C g margin corresponding to all available information. So, as discussed in the previous discussion session, the first basic step is to draw the fuselage line, mark a place for neutral point that should be behind the place you mark for C g. It is okay if you show this to be the static margin or just write static margin, or you draw a wing and then show that this is x C g and this is x neutral point and this is static margin, that is fine too. So, the grading for this question is going to be, for question 1 part 1, it will be 2.5 plus 0.5, where 0.5 is for arithmetic, whether you make one calculation mistake or two, I will take away half, and 2.5 is for using the correct equations. Second, same, using the correct equations and derivation, 2.5 plus 0.5, and third is going to be half and half, basically half for the figure and half for the label of the static margin. Okay. Moving forward, going on to the next question. So, again no need to read all of the information that is given at the start of the question. We have, our target here is to determine the center of gravity position for 20% static margin. So, again when you start with center of gravity, you have to start with the static margin. So, you get x neutral point minus x C g divided by C bar, and this has to be 0.2, right. Now, I know that the only unknown that I am looking for is this, and I do not have this. So, now the question becomes to go and find neutral point, because once I have the neutral point, I would have x C g equals x neutral point minus 0.2 C bar. Okay. So, now my problem is of finding the CG becomes of finding the neutral point, and remember the definition of neutral point. Neutral point is the point about which the total moment about the aircraft does not change, which means that the constant part is non-zero, may be non-zero, but Cm alpha about the neutral point is going to be 0, right. So, even if you did not have the equations for contributions, which means that, and since fuselage contribution is to be neglected, which means that the contribution of the wing to Cm alpha neutral point plus the contribution of the tail to Cm alpha neutral point must be 0. Now, even if you did not note down the contributions for neutral point, it is fine, because you can simply write down the contributions about the CG. So, write down the contribution about the CG, x CG minus x AC wing divided by C bar minus eta t S tail by S x AC tail minus x CG divided by C bar times CL alpha tail times 1 minus d epsilon by d alpha. Now, this gives me the contribution about CG. So, just change the location about which you are taking the moment. So, this becomes the contribution for neutral point, and this should be equal 0. Now, CL alpha, I go and look piece by piece that can I find CL alpha, cap CL alpha? Yes, I can. Why? Because I have been given C small l alpha. So, this is the 2D, I have the aspect ratio of the wing. So, I can get CL alpha done. X AC of the wing, since nothing is mentioned about the aerodynamic center, feel free to make the approximation that this is 0.25 C bar. Eta tail is given as 1.0, S tail and S. So, now you are not given the areas directly, but it is a very simple geometrical problem. You are given that the span here for the wing is 10 meters and the and the aspect ratio here is 10, which means this width is going to be 1 meter. So, area is going to be 10 meter for S, and for the tail you have the width as 5 meter, aspect ratio is 6, which means that this is going to be 5 by 6 meters, which means that S tail is going to be 25 by 6 meter square, this is meter square. You plug that in here, you get S tail by S. Now, X AC tail. X AC tail is 0.25 times C bar of the tail, but this is C bar of the wing. So, you need C bar tail by C bar wing, which is very straightforward. You have C bar tail as 5/6 of the meter and this is 1 meter. So, this is 5 by 6, which means this is 0.25 times 5 by 6 or 1.25 by 6. CL alpha tail the same way that you found CL alpha wing, and 1 minus d epsilon by d alpha, use the 2D lifting line theory to approximate it by 2 CL alpha wing divided by pi AR wing. Everything in the equation is now known and you can express the value of x neutral point. Once you have that, you go and feed it in here, you have the location of the CG. So, the grading scheme for this is going to be something like, if you have this equation, then you get 1 mark. That is basically, I can see that you understood that finding the CG means finding the neutral point first. Then you go ahead and use the right equation, you get 2 marks. If you have written any equation in terms of lift, it will not contribute to any score. If you have written equation in moment, but it is incorrect, you will get somewhere between 1 to 1.5 inclusive of the limits, and if you have used the correct equation, then 2. And finally, the rest of the score is distributed like finding this is 1, finding this is 1, finding this is 1, and finding like the rest of the values, the approximations are half and half and half. So, total 7 points. Now, moving on to the last question. So, again first go and find out what we need to find out. Rudder deflection required to trim the airplane at the instant the tail wheel leaves off the ground. So, if you haven't watched the last discussion session, the last 5 minutes I have discussed that how does a single propeller aircraft generates asymmetric thrust, which would help you with some understanding of the question, but is not necessary for getting the question. But first you need to make a figure to understand the problem. So, what's the problem? There is an aircraft, it has wings, it has a horizontal tail and it has a vertical tail which has a rudder, and then it has a propeller here which is inducing. So, it is given to us that C n due to the thrust or due to the propeller is 0.02, which is positive, which means that the thrust due to the propeller would be half rho v square S b times 0.02, which means that N p is positive. So, z axis goes into the aircraft, which means this direction is N p, which means the thrust asymmetry must be like the thrust due to the propeller might be acting this way for some offset distance, which means that I need to turn or provide a counter moment from the rudder which takes it the opposite way. To take it the opposite way, I need the small lift on the rudder to be in this direction, because the C g is somewhere here. So, the moment has to be negative, which means that my deflection must go this way. Now, go and look into your cheat sheet. Deflection to the left gives me that delta r is positive, which means that whenever I get my answer, delta r should be positive. This is one sanity check, this is important. Now, I will go and write down the moment balance for yaw, which means that moment due to propeller plus moment due to rudder is going to be 0, no yawing, equilibrium. Go ahead and write this half rho v square S b times 0.02, same half rho v square S b times C n delta r times delta r equals 0. This part is common, I can simply throw it out, and I have 0.02 plus C n delta r times delta r equals 0, and C n delta r is nothing but negative eta vertical tail, volume vertical tail, CL alpha vertical tail, tau rudder times delta rudder equals 0, which means that delta rudder is going to come out as 0.02 divided by eta vertical tail, volume ratio vertical tail, CL alpha vertical tail, tau rudder. So, yes, all of this is positive, this is positive. So, yes, my delta r should be positive. Now, go ahead and find this, this is given, go ahead and compute this, go ahead and compute this, go ahead and find this from the graph. So, if you have found out that delta r is positive, you get 1 marks, like 1 score. If you have found out that this is the equation, then this is 1, and the rest of the force is divided here in finding the 4 variables. And if you have made an attempt somewhere which leads you to the correct answer or shows me that you are using the correct concept, then you will get partial grading as well. Any questions? Yes.
For the NP plus NR equals 0, will I get partial credit if I just like put it as CNP plus CN?
Oh yeah, whether you write it in the force or the coefficient format, if you use P sub T, I do not care, but the balance should be shown somewhere. Yeah, that is all.